Welcome back to Arcade. I am Super Tommy. This is a video series on creating the ghost AIs in Pac-Man. Now, in the last video, we added Inky's AI. That's this blue ghost. And you see that Inky uses Blinky as his partner in crime to pick a spot to go to flank Pac-Man. So now in this video, we're going to look at Clyde. Now, Clyde, his AI is that when Clyde is more than 8 tiles away from Pac-Man, Clyde uses the same AI as Blinky, the Chase Hero AI. And then when Clyde is within 8 tiles of Pac-Man, Clyde uses the Scatter AI and goes back to the bottom left corner. So we covered the Chase Hero AI and the Scatter AI in 2 previous videos. So do check those out if you've missed them. So now let's implement the Playfully Chase Hero AI, as we're going to call it, for Clyde. So we'll just make a new class here. Playfully Chase Hero AI. All right, so let's make class. And then we implement the Ghost AI interface like we've done for the other Ghost AIs that we've done already. And let's go to this interface. We need these 3 things. Get speed 100 target. We're just going to do a bare bones implementation of this class to remove these errors. Okay, so we're going to compose 2 AIs that we already used to make this AI. So let's see here. Constructor, we know we are going to need some things for this to work. So let's see. First thing, we know we need the Chase AI. So let's just say we want the Chase Hero AI. And interesting, I'll just manually import Chase Hero AI from Chase Hero AI, and we're going to want the Scatter AI. Scatter AI. Okay. Chase AI, Scatter AI. So now we could make the Chase and Scatter AI in here instead of getting it passed in to us. It's probably more flexible if we had it passed into us than creating in the class ourselves. So that you can get, I guess, different types of Chase AI and different Scatter AI logics if we wanted. Right now, this is the concrete implementation that we're getting. So you would have to like subclass the Chase Hero AI and then make a new one yourself. But what you could do in your own implementation is to use a interface like we're doing with the Ghost AI here. Okay, Chase AI, Scatter AI, and then so what we're going to do, so we need to know distance and tiles from Pac-Man. So let's say we will need to know where the hero is. So let's actually take those 2 AIs and then get hero. So private hero. And so the ghost. So we'll also need to know the ghost. So let's make ghost first. The actual ghost that this AI is going to belong to. So computer private ghost. And then this dot ghost is ghost. So in this entire series, we've been taking things from in the constructor. This is called dependency injection, or both, I guess, poor man's dependency injection. In a lot of DI, dependency injection frameworks, they'll handle this for you, and you'll have like a little decorator in for example. And then you can define what you want to inject. I think another language is called attributes. I think in Java they're called attributes, and C# they're called attributes. Don't remember. But so this is basically what dependency injection is. You just pass in all your dependencies opposed to creating them in your class. And there's many reasons why that's better. We won't go over that in this video, but it does, your code is more readable and you're not creating things inside your class that is basically hidden. So you know everything you need for this class to run, and it's all given in the constructor. Okay, so now what we're going to do is if the hero, Pac-Man, is more than 8 tiles away from the ghost, we're going to do the chase AI. So let's use distance. So we're going to call this HXHY hero. So we're going to use object destructuring here again. We went over that, I think, in part 3 or part 2 for object destructuring. If you want, go check that video or just Google object destructuring in modern JavaScript or ES6 JavaScript or TypeScript. So this dot hero dot position body dot position. Okay, so the position of the hero. Now we want to know the position of the ghost. So we're just going to say ghost position is just XY, and then this dot ghost dot physics body dot position. So now we want the distance, and that's going to be phaser dot math dot distance between, and you give it 2 points. So we're going to do HX, HY, X, and Y. This is going to be the distance between Pac-Man and the ghost. So we want tile size. Nope, not const tile size. So let's just go with what should we call this? Min distance, max distance. Let's call this min distance. It's going to be tile size times 8. So if it's within 8, let's just call it radius. Right, within 8 tiles of Pac-Man, so radius. So if distance is less than, no, it's greater than radius, right? So it's more than 8 tiles away. We are going to do this dot chase AI dot pick direction. We're going to delegate the logic to chase AI when the distance is more than 8 tiles away from Pac-Man. And otherwise, so then that would mean it is less than or equal to radius. We're going to do scatter AI dot pick direction. Okay, that looks good. So now let's go to our game class and try this out. So we are going to make Clyde new ghost. This, and I guess 288 plus 32 is 310, right? Plus that's 90 plus 30 math. So 3, that's 2 plus that's 320, right? Let's see. Doing math on the spot is hard. Board layer plus 2 is 290. Yeah, 320. Okay. Okay. Make orange. Let's enable the target marker. And then Clyde.setAI, we're going to do our playfully chase AI. So import playfully chase hero AI from game new ghost AI, playfully chase hero AI. So new playfully chase hero AI. So first thing, ghost. Then a new chase AI. Okay, so let's do it this way. And then new chase hero AI. And the ghost is going to be Clyde. The hero is going to always be hero. And then this is the board layer. And then next thing, scatter AI. Let's just make sure I have the right scatter AI imported. Yeah. Scatter AI. So we're going to scatter to the bottom left, which is 0, this dot border layer dot height. And the ghost is Clyde in the board layer. And then hero, so this dot hero, and there we go. So there we go. This is the playfully chase hero AI that takes a ghost, the chase hero AI, the scatter AI, and the hero. Okay. Let's see. Now we add existing Clyde. Let's see what we got. Clyde should be over here. There he is. So Clyde comes down here. So as you can see, because Clyde is so close to us, Clyde is now circling the bottom left. So if we move more than 8 tiles away, you should see, yep, Clyde's going to now follow us again in Chase AI. So that is pretty cool, right? So if we just stand here, Clyde will go away. But he will never make it all the way back before coming back around. Yeah. So that is a Clyde's AI. So now let's actually just add, we have Blinky, let's add Pinky. Const Pinky, new ghost. This, so we're just going to add Pinky to, so we have 256, 288. Let's do 256 minus 32. So 256 minus 32 is 224, I think. This dot board layer, okay, dot make pink, that's Pinky, dot enable target marker. Okay, and then Pinky dot set AI. So this is new intercepts, right? That's the interceptor. Yeah, the interceptor. Pinky, this dot hero, this dot board layer. Okay, this dot add dot existing Pinky. So with a dependency injection framework, just briefly like what we talked about, and there's Pinky doing his intercept, is you can sort of save having to do this manual managing of your dependencies and passing them all in the right place, especially when you get to here, right? What the DI framework would do for you is like handle that for you, and then you would just define where you want things injected, and it will just figure out which interfaces, which instances belong to which interfaces, or which concrete implementations belong to which interfaces, and then figure that out and inject it into your class when it's created. So there are some JavaScript DI frameworks you can look them up on Google, but basically it is doing this, and you can manually do it. It is equally as effective, albeit a little bit messier. Okay, so we've got Pinky up here. We've got all the ghosts up here. And you can see the pink, that's the pink target. That's where Pinky's going. So let's actually, so Blinky right now is confused. That may be one of these issues where there's some tricks based on the AI of these ghosts. You can like put Pac-Man in a specific place and then they'll never actually hit Pac-Man. So I'm going to just move this so that we can see it a little bit better, but still have it in the bottom corner. So let's see. All right, let's bring them on. So where exactly is the orange? It should be over here. Let's just do a little x32. Let's just go 512. We know where 512 is over here somewhere. Just make sure that scatter is happening. It looks like it's happening. Enable target marker. Just want to confirm. Oh, yes, we didn't. I don't know. Make red, make pink, make orange. Okay, let's go to the debugger and just make sure that our Clyde implementation actually worked. We called it playfully chase. It could always be the case that our logic is incorrect here. Let's see. Okay, so distance, well, we have h, okay, hx hero, about 128, that sounds right. Down below, oh, this is 512, good. And then that's the scatter position. No, this is the ghost. Yeah, so he's down here, 32, and that, okay. Then let's see what the distance is. Right, I am blocking it. Distance. Distance is 160, and the radius is tau size times. So let's just step over. Radius is 256. So distance is definitely not greater than radius. Great. Now let's step in. So target position. Let's see. Target position is 32, 5, 12. Now, of course, oh, yes. Silly me. Let's go back here and disable this. Okay, so I missed a part here with this target. It's always 0, 0. But the target actually should be, let's just do this so we can see it. Target position, x, 0, by 0. Let's just return. Oops. Okay, so if it's going to do that, let's just do this. Just to get the target position after the chase AI has done its thing. And we'll do the same here. And this is scatter AI, and then return the selected direction. Okay. Too much recursion. What do you mean? Let's stop this. Too much recursion. Did I do something silly? Let's just undo. Let's see what I missed here. Oh, yeah, that's too much recursion. That was an error. Okay, let's set this back. So sometimes, of course, IntelliSense and autocomplete actually hurts if you are not paying attention. Chase the eye, target position, okay. Conster, return, okay. So target position, oh, chase the eye again. Also copy and paste. Let me just not open the debugger. Just lose it down. So there's the orange. So now I just change this back to what it was. All right, so now orange and red, everyone's on top, or most people are on top of Pac-Man. And then there it is. So it's going to the left corner. Right there you can see. So Clyde is working, so we move away. And now the orange is back on us, but there's a bunch of people chasing Pac-Man right on top of him. Whoa. And then somehow Clyde went super crazy. What is Clyde doing? So Clyde just ignored the walls a bunch of times. Let's see if we can get that to happen again. No, it could be something we've just missed, but it generally works. And so the takeaway here from the Playfully Chase Hero AI is that how we are using the existing AIs we already made to compose this newer AI behavior just using the sort of things we've already done. So that's another one of the benefits of extracting out and that happened again. Um, Abstracting out this logic, you can combine and compose them easily with each other. So that is all the Pac-Man Hero AI. There's resources on the arcade blog if you want to do something like this.add.ghost, for example, instead of doing new ghost and then adding it to the scene like this. We actually did do that in our create here, you can see. So you can find an article on that if you are interested. If you go to the arcade blog and look for the game object factory, just do a search, and in this article right here, it'll go through how you can augment Phaser's game object factory to add your own factory methods. So that's it for this 5-part series on the Pac-Man Ghost AI. Thanks for watching.